Hey guys, in this video we are going to be talking about how to graph exponential functions using Desmos. All right, so this is going to kind of bring together all of the things that we've learned throughout the year about how to use Desmos. We're going to input a table into Desmos, we're going to find the equation of the exponential from Desmos, sketch the graph, and then we'll answer some questions as well. All right, so this is our very first problem here. So I'm going to switch us over to Desmos. And then I will go ahead and focus this. Okay, so let's get this to the home here. The first thing I'm going to do is input a table, which means you need to click the plus sign up in the left-hand corner and then click table. And all I'm going to do is input that table that was on the page, which you can see if you're looking at your own paper here. So 0, 5,000, 1, 5,400, 2, 5832, on down the line here. Okay, so there's the table that's on the page. Now we have a few questions that we have to answer. First of all, what we're going to want to do is we're going to have to find the equation of the exponential regression and write it below. So if you think back to the data unit, the first thing we pushed is this magnifying glass here, so we got a better look at the exponential itself. And then we want to connect the line, so we'll click this as well. Now, the first thing it's going to put up here is a linear regression. But we aren't dealing with a linear function here, we're dealing with exponential. So we're going to click the drop-down menu, and we're going to go down until you see where it says exponential regression. And you're going to click that button, and it will connect the dots properly for you, okay? So then what you want to do is write this equation you see right here underneath where it says equation. So that is y equals 5,000, and then it's times 1.08 to the x. So I'm going to put that 1.08 in parentheses because that's how we're used to seeing it. All right, so it's y equals 5,000 parentheses 1.08 to the x. All right, next thing we're going to want to do is we're going to sketch the graph on the paper. All right, so when I'm looking at this Desmos, I see that the x's are increasing by ones, but the y's are not. It looks like they are increasing by about 100. 1, 2, 3, 4, yep, 100 for each little line, but they're starting a little bit higher than 0. So that's what we're going to do when we go to put this on the page here. So let's flip back over, refocus, and then we will get started on that. Okay, so I'm going to number my x values, or my x-axis, by ones. And this is the number of weeks. And then I'm going to put a break in the graph like we learned previously so that I can start at, we'll see if 5,000 works. We'll probably have to graph it a little bit differently than they did on there, but that's okay. So 5, 51, 52, 53, 54, 55, 56, 57, 58. Yeah, we can't count by hundreds, but we will start at 5,000. And then we need to get all the way to 7,300. Let's see, 52, 54, 56, 58, 6. That won't work. So let's count by 500s. So this is 55. So this is 6,000. 65, 7,000. 75. We probably could have gone a little bit smaller. 8,000. And that's as high as we need to go for now. So we know that we have a point at 0, 5,000. My next point is 1, 5,400. So that's just underneath here. Then 2, 5832. So let's see, this is 55. It's very close to 6,000. Then 3 is 6298. So that's getting closer here. 4, 6802. 5, 73.46. Okay, it's looking a little linear here, but it should be curving up this way. Okay, so that's a rough sketch. All right, how many bugs were at the campground initially? You can look in a couple different places. You can look at the table, you can look at the graph, you can look at the equation. In each case, it's going to be the y-intercept, or the a value, or whatever a y is when x is 0. So that's 5,000 bugs at the start. All right, now what percent is the number of bugs changing by? The key word here is percent. The common factor is 1.08, but that is not the percent. So remember, if it's greater than 1, you need to subtract that 1 from it and then change the decimal to a percent. So I'm left with 0.08 when I take the 1 away, which is 8%. And it is increasing, so I'm going to leave that positive. All right, let's talk about domain and range of these types of functions. If you recall, domain are all of the x values that are being used in the function, okay? So x starts at 0, and it is inclusive. So it's from 0 till infinity. It goes on forever. There's no limit to how many weeks can go by. So when I explain what that means, that's exactly what I'm going to say. So time starts at 0 weeks and has no limit. Okay? Now let's talk about the range. Those are the y values. The minimum number of bugs is 5,000, and without any intervention, that number of bugs increases exponentially forever. So that means that 5,000 is the minimum number of bugs, and that can go on forever. And remember, we use parentheses when we're talking about the infinity. All right, so the number of bugs starts at 5,000 and has no limit. And that's it. Let's try another. All right, second problem here. The table to the right represents a city's population for the number of years after the year 2000. Use the table to answer the following questions. All right, so same thing, we're gonna have to use Desmos. So I'm gonna switch us back over to Desmos, and I'll clear out the last problem. Okay, so I'm just gonna hit the X here and the home button, and we will start again. All right, so the first thing we're gonna do is hit the plus sign so we can input a table. And I'm going to type the table in. So it was 0, 100,000. And 1, 96,000. 2, 92, 160. Good gracious. 3. That was supposed to be a 5. Okay, so there's our table. Again, I'm going to hit the magnifying glass and the regression line. But again, this is not supposed to be linear. I know it looks pretty close to linear, but this is exponential. So we're going to switch it to exponential regression, and it adds a little bit of curve there. And now I can write the equation. So it's y equals 100,000 times 0.96 to the x. Okay, now looking at this, 95, 96, 97, 98, 99. Again, it looks like they're counting by hundreds. Not sure that we will be able to do so, but we will do our best. So let's flip back to the paper. Get the all focused. All right, so we have our equation, and now we're going to sketch the graph. So once again, the x values are changing by ones. And this is the years. And then we need to go from 100,000 down to about 81,000. So again, we're going to use a break. So if we start at 100K up here, and this is going to be population in thousands. We need to get all the way down to 81. So I wonder if we count by fives. So 95, 90. No, that's not enough. Let's do 9, 9, 8, 7, 9, 6, 9, 5, 9, 4, 9, 3, 9, 2, 9, 1. That's not enough. Let's do twos. 98, 96, 94, 92, 90, 88, 86, 84, 82, 80, 78. That'll work. Okay. All right, so now we're going to plot the points. We know that it starts at 100,000. That's right up here on the y-axis. Then we had 196,000. And then 2 was 92,160, so slightly above here. 3 was 88,473, so here's 88, close to the middle. And then 4 was 84,000, so almost 85. So here's 84, so towards the middle. And then 81,000. So here's 80, 81, somewhere up here. So again, this looks a little linear, but it is supposed to have a bit of a curve to it. Okay, so there's our exponential sketch. The initial population, remember, is the y-intercept, what y is when x is 0, or the a value. In any case, that's 100,000 people. Okay, what percent is it changing by? Now this is decay, right? So the common factor is 0.96. But you have to subtract that from 1 to find what the percent is changing by. If I do 1 minus 0.96, I get 0.04. So that means, first of all, it's decay, so it's negative. 0.04 as a percent is 4%. So it's losing 4% each year. All right, let's talk about the domain. It's still 0, and it can go on forever. So time starts at 0. And has no limit. Okay, but when we talk about the range, okay, we know that the maximum is 100,000. The minimum is, it's not going to hit 0 necessarily, but it's going to approach it. So I'm still going to put 0 here for my minimum, but I'm going to leave that open because an exponential function does not actually touch the asymptote, it's called. In this case, it doesn't touch the x-axis. So it's going to approach 0, but not quite reach there. And it's going to go all the way up to 100,000 because that was the starting amount of the population. Okay, so the population max is 100,000. And it will approach 0 over time. And that's it. That's how you use Desmos to graph an exponential function.